My name is Madhuri from ASSMS IOIT College. So in today's video, we are going to discuss the Cohen sutherland line flipping algorithm. So there are some steps of algorithm Cohen sutherland line flipping. So the first step is to calculate the position of both endpoints of the line. Second, perform the AND operation on both of these endpoints. Third one is if the AND operation gives 0, 0, 0, then the line is inside to be visible, else perform the AND operation on both endpoints. If the result of AND operation is not equal to 0, then the line is invisible. If it is equal to 0, then the line is considered as a flipped case. So it is a visible line, so it is in the flipped case. So if a line is in flipped case, then find an intersection with the boundaries of the window. So we get the 4 bits. So if the first bit is line intersected with left boundaries of rectangular window, then we have to calculate the y3 equal to y1 plus mx minus x1, where x w mean is the minimum value of the x coordinate of the window. Suppose the bit 2 is 1, then we are calculating the x coordinate of the values, that is the x max value. Suppose the bit 3 is equal to 1, then we are calculating the y mean values of the y coordinate of the window. Suppose the bit 4 is 1, then we are calculating the y max values of the y coordinate of the window. Next, so see, this is the example of Cohen-Sutherland line flipping algorithm. So we already discussed the steps of the algorithm. So with the help of that algorithm, first of all we have to calculate the end points of the line. So see in the figure, this is the AB is the line. So we are calculating the bit values of the A vertices and the bit values of the B vertices. So the value of A is 0, 0, 0, 1 because the point A is arises in the portion which having the bit code as the 0, 0, 0, 1. Okay, so the B, that is the -1, 7, having the bit code as a 1000. So we are calculating for each and every point as a bit value. So for point C we get the 4 times 0. For point D we get the 1010. For point E 4 times 0. Why 4 times 0? Because it is lies in between the mid part of the coordinates, that is it is in the, we directly decided that it is inside the polygon. So f is also inside the polygon and the value of f is also 4 times 0. So the g having the 0, 1, 1, sorry 0, 1, 0, 0, h having the 0, 1, 0, 0, point I having the bit as a 1001 and the j having the 1000. So first step is we have to calculate the end points of each and every line. Then we are finding the if the end points is equal to 4 times 0 or not. So see in this figure, the E and the F both are the end point of the same line and the both are having the 4 times 0. So since the region code of the both endpoint is 4 times 0, so that means it is a visible line, fully visible line. So the next step will be, suppose some having the not having the values like the 4 times 0, then that means it is a not visible line. So we have to calculate the AND operation between that two endpoints. So ij is a line which having the endpoints is not equal to 4 times 0. That's why we have to calculate the AND operation between the two vertices. So when we calculating the AND operation between the ij point, then we get as a result 1 0 0 0. That means which is not a 4 times 0. That means the line is not visible. So in the third step, we have to calculate the candidates for clipping. Means we have to calculate which lines are clipped here. So first of all, we calculate the visible lines. Then next one is the not visible lines. Then the remaining lines are the candidates for the clipping. So AB is a line, CD and the GH. So first of all, we calculate AND operation for the AB line. Then we get the 4 times 0. AND operation for the CD line. Then also we get the 4 times 0. AND operation for the GH line. Then also we get the 4 times 0. That means the three lines are the candidate for the clipping. So A, B, C, D and the GH, we are selecting these three lines and then we are calculating the intersection point for each and every line. So first of all, we calculate the intersection point for the AB line. So the bit code for the A point is the 0001 and the bit code for the B point is the 1000. So see in the figure, the AB is a line, A having the point -42 and the B having the point -17. So this line is intersect at 2 points. Okay. So I1 is a 1 point and the I2 is the second point. So we have to calculate the bit code for the I1 and the I2 also. So we take I1 as a 4 times 0 because it is available on the boundary of the polygon. So the I1 value is the 4 times 0. So first of all, we perform the half portion of the line, that is the A to I1. Next, we are calculating I2 to B. Okay. Then we are calculating only the flip portion, that is the I1 to I2. So first of all, when we perform the AND operation A to I1, then we get the 4 times 0. Then again we are calculating the AND operation towards the I to B. Then also we get the 4 times 0. Then we are calculating only the intersection points I1 and the I2. Then we get as a result 4 times 0. That means the 0. So it means the all result is the 0. That means we clip the line AB at the intersection point as a I1 to I2. So similarly, we are calculating the intersection point for CD also and the GF also. So finally, we get the lines as like see in this polygon, we get the line as a C, I2, EF and the I2, I1. Okay. So this is the portions which is arises in the polygon, and with the help of Cohen's Sutherland line clipping algorithm, we clip all the lines which is present in the polygon. So it is a very simple algorithm to find out the clipping line. So thank you all.